Maxon motors can be made with different windings. This third chapter deals with the properties of the winding series. In the Maxon catalog, the different windings of a motor types are listed in columns. The column order stems from the winding resistance that increases from left to right. The first winding on the left is made with a wire of the largest diameter. Only a few winding turns can be placed in the air gap between housing and permanent magnet. Correspondingly, the resistance is low and only a low voltage is needed to drive relatively high current. The last winding on the right is made with the thinnest wire and many turns. The resistance is more important and the required voltages are high, but there is only a low current flow. How do the motor limits change over the winding series? The maximum motor speed is a motor type parameter. The value is the same for all the windings. The nominal torque, it is the border of the continuous operating range, is almost identical for all the windings. We have to conclude that the mechanical motor limits, speed and torque capabilities are independent of the winding selection. How does the speed-torque line change over the winding series? The speed-torque gradient is almost identical. Each winding has its particular nominal voltage. It is selected to give a similar no-load speed for all the windings. Accordingly, the stall torque is very similar too. Again, from a mechanical point of view, we get a very similar behavior for the different windings. Here is a graphical representation of the windings of the previous slide. The operating range diagram of one winding can stand for the full winding series. The speed-torque lines lie in a narrow band. This is how the nominal voltage are assigned. Points to remember. For a given motor type, the mechanical behavior and the motor limits are essentially identical, regardless which winding is taken. From a mechanical point of view, load operating points can easily well be reached with any winding. Let's now turn to the electrical side. How do voltage and current vary over the winding series? The assigned nominal voltage increases with increasing winding resistance. All the current values are highest for the low resistance winding. This means for the same torque to be generated, a low resistance winding needs more current. The same power can be obtained with a low resistance winding at low voltage and high current, or with a high resistance winding at higher voltage but lower current. Any winding can reach similar speed and torque, however, with different electrical input voltage and current. The increasing voltage over the winding series is counteracted by the decreasing speed constant. As a result, similar output speed can be reached with the different windings. An analogous statement can be made about current. The lower current of the high resistance winding is compensated by a higher and higher torque constant, resulting in the same output torque. Here is a graphical representation of the previous slide. However, this time we observe all the windings at the same voltage of 24 volt. That's typically what you have in an application. The available voltage is given. Selecting the winding with nominal voltage similar to the available voltage may not be the right choice. Here, the acceleration cannot be fully achieved when selecting the winding with 24 volt nominal voltage. The winding to the left with a higher speed constant and nominal voltage of 18 volt covers all the operation point easily when operated at 24 volt. A speed or position controller will adjust the motor voltage to the lower values needed. However, the current requirements are higher, as can be seen by comparing the needed current for 10 mN of torque. The windings with even lower nominal voltage of 12 volt or even 9 volt won't make good use of the available voltage. The controller would have to reduce the motor voltage a lot, and the currents needed are much higher. The other two windings with higher resistance and nominal voltage cannot reach the required speed, because their speed constant is too low. The key message is, select a winding with a high speed constant, but don't go too high for keeping the required current small. Some key messages to keep about motor windings. All windings of a motor type can produce the same mechanical output, it is speed and torque. From left to right, the winding needs more voltage, but less current. Select a winding that fits best your power supply. That's it. By the way, you can find chapter 1 and 2 of this tutorial in separate videos. They explain motor operating ranges and motor behavior.